Welcome to today's lesson on understanding what is meant by a wave. Our plan for this lesson is as follows. We will begin by learning the definition of a wave. We will then clarify this definition by presenting some visualizations and highlight the key point that waves transfer energy, not matter. So far, we have explored basic physics concepts such as energy transfer and the behavior of particles in different situations. Building on this foundation, we can now delve deeper into the concept of waves. Understanding waves enhances our comprehension of various natural phenomena, such as sound, light, and even seismic activity.
So, what is a wave?
A wave is a disturbance or oscillation that travels through a medium, transferring energy from one place to another. Examples of these mediums include water, air, and space. This definition means that waves are the way in which energy, not matter, is transmitted across distances. There are two primary types of waves that we need to understand: transverse and longitudinal waves. We will expand on these wave types in the next lesson. Let's now look at ways we can visualize waves. Imagine standing by a still pond. As soon as you drop a pebble into the water, ripples emerge from the point of impact. These ripples are waves. Each ripple represents the transfer of energy through the water. When you drop a pebble into water, the initial impact transfers kinetic energy to nearby water particles. These particles vibrate, passing energy to the next set of particles, and so on, causing a ripple. The wave moves through the water by transferring energy from one particle to the next. However, note that the wave only transfers energy, not matter. If the water molecules themselves moved outward with the waves, the water would have eventually piled up at the edge of the pond. But this is not what happens, so we know that it is only the energy being transferred, not matter. Let's take another example. When you speak, your vocal cords vibrate, causing nearby air particles to oscillate. These vibrating particles transfer their kinetic energy to neighboring particles, and the sound wave moves forward. Note that the air particles vibrate back and forth, but do not travel all the way from your mouth to the listener's ear. If the air particles did travel this distance, you would be left with a vacuum around you every time you spoke, leaving you with no air to breathe. Again, we know that this is not what happens. So this emphasizes how waves are a transfer of energy, but not matter. Understanding what waves are and how they function is crucial, because waves occur in many different forms in nature. From the waves in the ocean to the sound waves we hear and the light waves we see, waves are integral to how we experience the world. This knowledge helps us understand more complex physical phenomena and prepares us to study various kinds of waves and their behaviors in different contexts, such as optics, acoustics, and even earthquakes. In today's lesson, we delved into the concept of waves. We learned that a wave is a disturbance or oscillation that travels through a medium, transferring energy from one place to another. We noted that these mediums include air, space, and water. Next, we visualized waves through examples like ripples on a pond and sound waves, noting that waves transfer energy through particle vibrations. We also emphasized that waves only transfer energy, not matter. This foundational knowledge prepares us for more advanced studies of wave types and their behaviors in different contexts, setting the stage for deeper exploration in upcoming lessons. Watch the rest of the GCSE physics course at Sophos Education.